Prove by induction for all natural numbers that if we raise this matrix to the power of n, then we'll get the matrix on the right. Okay, let's start with n equals 1. So the left-hand side is just going to be minus 5, 9, minus 4, 7. And the right-hand side is going to be 1 minus 6, 9, minus 4, 1 plus 6, which is then minus 5, 9, minus 4, 7. Okay, so true. True for n equals 1. So now we're going to assume that it's true for n equals k. Therefore, minus 5, 9, minus 4, 7, the k is equal to 1 minus 6k, 9k, minus 4k, 1 plus 6k. And show this implies that true for n equals k plus 1. Just going to put this bit in brackets. So what we want to get to is that this is equal to 1 minus 6k plus 1, 9k plus 1, minus 4k plus 1, 1 plus 6k plus 1. Okay, well, let's start with the thing on the left then. So minus 5, 9. That's just to say, like, I'm assuming you've done plenty of proof by inductions, but we want to show that if it's true for n equals k, then it must then be true for the next one on, n equals k plus 1. What that would mean is because we've shown that it's true for n equals 1, that n equals 1 implies n equals 2, n equals 2 implies n equals 3, and so on. Essentially, a domino effect begins, like forever. So we start with the k plus 1 term, and I'm going to write this as minus 5 minus 4, 9, 7, multiplied by minus 5, 9, minus 4, 7 to the k. You could do it either way around, it doesn't actually matter. And now this is where I use my assuming true for n equals k. I'm going to replace this by this. Okay, and then let's multiply this out and try and get the green matrix here. So I've got minus 5 plus 30k minus 36k. I've just dealt with this row and this column. And then it's the same row, but this column. So minus 45k plus 9 plus 54k. Okay, these are separate elements. I'm just going to draw a little dashed line. Now onto the row below in the first column. So it'll be minus 4 plus 24k minus 28k. Finally, minus 36k plus 7 plus 42k. Let's simplify before we try and bring it together. So minus 5 minus 6k minus 4 minus 4k 9k plus 9 6k plus 7. And then I can try and write it as above. So I can see if I expand this, I'm going to get 1 minus 6k minus 6. That will become minus 5 minus 6k. So I can just go the opposite way. And then 9k plus 9 factorizes to 9k plus 1. Factorize out the minus 4 here. And then 6k plus 7 is 1 plus 6k plus 1. So we've written it in the form required. So therefore, true for n equals k plus 1. Since n equals 1 true, and n equals k implies n equals k plus 1, then by the principle of mathematical induction, the statement is true for all natural numbers n. Okay, well done.